Good morning, Doctor and my fellow teammates. Today, I would like to introduce the assignment and mini project that we have done during this semester. The title for our assignment and mini project is Image Processing Techniques for Enhancing Disease Features in Chili Leaf Images using Matlab. The group members for this project is Siu Kamen, which is me, and one of my partner, which is Yap Tai Xiang. Okay, let's proceed to the introduction of this project. Agriculture plays a vital role in food production and economic growth. Plant disease significantly impact agricultural productivity. Traditional detection systems often face challenges due to image processing limitations. So, modern agriculture is encouraged by using image processing techniques to enhance disease feature visibility and support disease diagnosis. One of the famous platforms to implement advanced image processing techniques is Matlab. Let's proceed to the research gap of this project. One of the research gap is limited focus on disease feature enhancement in existing studies. What is the features? Based on the figure below, which shows a leaf spot of a chili image, the features in this image is the leaf spot. Moreover, the second research gap of this project is inadequate comparison of image enhancement techniques such as age detection, image filtering, image deblurring, and so on. The third research gap of this project is underutilization of Matlab for agricultural image processing. And lastly, the fourth research gap of this project is the need for effective pre-processing to improve classification accuracy. The software we use for this image processing project is Matlab, which is shown in the figure below. Matlab is a high-level programming platform developed by MathWorks. It supports image processing, visualization, and data analysis. The key features of Matlab includes noise reduction, contrast adjustment, and age detection. It also enables accurate enhancement of disease features in chili leaf images. This is the list of the image processing techniques, where number 1 to number 5 will explained by me, and number 6 to number 10 will explained by my partner Yap. First and foremost, one of the image processing techniques we use in this project is image detection. Image detection is used to identify and detect the discontinuities in the image intensity and extract the outlines of disease features present in the chili leaf images. There are a total of 2 types of edge detection that we are used in this project, which is sober edge detection and canny edge detection. Sober edge detection is a gradient-based method that uses convolution operation with specific kernels to calculate the gradient magnitude and direction at each pixel in the disease chili leaf images. On the other hand, canny edge detection is a multi-stage algorithm that detects a wide range of edges in diseased chili leaf images, which is commonly used in noise reduction. The figure below shows the original image of a lotus plant, and the middle image shows the image after applying canny edge detection. And the rightmost image is the image shown after applying sober edge detection. Based on this image, we can see that canny edge detection has more obvious outlines as compared to sober edge detection. Let's proceed to the result of edge detection. 194 times 259 times 3 indicates the input image is a color image with a red, green, blue channels, and it is converted to grayscale image. The message is shown here to notify that the user has already converted the image to grayscale. Moreover, the first image below is converted to grayscale to simplify data by removing color information and only retains its intensity value. The figure in the middle shows image after applying a sober method. The sober method calculates the gradient of image intensity in both horizontal and vertical directions, aiming to highlight the edges. While on the rightmost image, it uses canny method to produce a sharper and cleaner edges, which is more effective in fine detail detection. Next, the second image processing technique is image filtering. Image filtering is used to enhance the image quality by eliminating noise, balancing intensity and color distributions via histogram. There are 2 approaches to perform image filtering, which is RGB histogram filtering and grayscale histogram filtering. RGB histogram filtering is to enhance and balance the color distribution of the images, and grayscale histogram filtering is to improve the contrast and intensity distribution in monochromatic images, enhancing the feature extraction of the diseased chili leaf images. The figure below, which is the left side figure, is the RGB histogram filtering, and the right side is the image for grayscale histogram filtering. The green channel at the figure below has higher pixel count at medium intensity value, which lies between 100 and 150, with the highest peak around 130. This result is expected due to the dominant color for a leaf is green. Moreover, the original image is converted to a grayscale image from RGB image, where the pixel intensity range from 0, which is black, to 255, which is white. This is indicated in the figure on the rightmost. The peak of the histogram, which shown in the left below images, indicates the intensity level where pixel counts are concentrated. The higher the peak in the mid-range, the most pixel intensity are in the medium brightness range. Next, image deblurring is one of the image processing techniques to remove the blurring artifacts from the diseased chili leaf images to restore original and sharp content of the images. Motion deblurring algorithm using mathematical models to counteract motion effects, whereas the convolution reverses the convolution process causing blurring. This algorithm is implemented in this project through the Matlab platform. CNN, which is convolution neural networks, falls under deep learning's revolutionized deblurring by learning complex features for sharpness restoration. The figure below shows an input image, and the middle image is after adding the blurring effect and noise, and the rightmost image is the restored image, which undergoes image deblurring. The original leaf curl image, which is at the left side, is an unprocessed image which has no visible distortion or blur. So, a motion blur effect is added into the original image to simulate real-world situations such as camera shake or motion detected during image capture. The blur image has a smear appearance along a particular direction, which makes the fine details harder to distinguish. Image deblur, which is an image processing technique, is processed using deblurring algorithm to restore its sharpness. So, it is able to estimate or compensate for the blur kernel and restore the details in the leaves. Noise cancellation is also one of the image processing techniques used to enhance the image quality by removing various types of noise, such as salt and pepper noise and Gaussian noise. There are three common approaches to perform noise cancellation, which are mean filtering, median filtering, and Gaussian filtering. Mean filtering is responsible for image smoothing by replacing pixel values with the average of their neighborhood to reduce the noise at the cost of blurring edges. Moreover, median filtering is responsible for replacing each pixel value with the median of its neighborhood, which makes it effective against salt and pepper noise. Lastly, Gaussian filtering is very effective to remove Gaussian noise, which applies a weighted smoothing kernel based on a normal distribution. The figure below shows is the original image and the image after applying a median filter. The leftmost image shown is the original image and the image after applying Gaussian filters. First and foremost, mean filter is used to smooth the image by averaging pixel values in a neighborhood. Based on the figure below, the noise is reduced and fine details are also blurred. Moreover, the median filter shows significant noise reduction with well-preserved edges, as the image shows in the middle. It works by replacing each pixel with the median value of its neighboring pixels to remove salt and pepper noise. Lastly, Gaussian filter works well in smoothing images by using a weighted average with more emphasis on central pixels, where noise is moderately reduced with some retention details but slightly edges. So, in overall, as a comparison, median filters provide the best noise reduction for salt and pepper noise while preserving details and edges. Mean filtering resulting in significant smoothing but also blur both noise and the details. And Gaussian filters can balance noise reduction and detail retention but is less effective than median filters for salt and pepper noise. Hence, the median filter is the best approach in performing noise cancellation. Color temperature adjustment is also one of the image processing techniques used to modify the perceived warmth and coolness of the image by altering the intensity of red, green, and blue channels. To achieve a warmer tone of an image, the red and green channels need to be increased, while the blue channel needs to be decreasing slightly, as shown in the rightmost of the figure. In contrast, the blue channel needs to be increased and the red channel needs to be decreased to achieve a cooler tone in an image, as shown in the left side of the image. The original image shows the unprocessed leaf spot chili image. Warmer color temperature indicates that the image color balance has been shifted to emphasize warm tones, which consist of red and yellow. Cooler color temperature indicates that the color are adjusted to cooler tones, which contain blue and green, creating a cooler overall effect. Custom RGB adjustment is a manual enhancement where specific RGB values have been modified to emphasize certain aspects of the leaf, such as leaf spots and veins.
Thank you, my partner Siu Carmen. I am Yap Taisan and I will continue with color features enhancement technique. This technique highlights the disease features in chili leaf image by emphasizing discoloration by using transformation in the HSV color space. HSV is a hue, saturation, and value. This technique transforms the image into HSV color space by facilitating better separation of hue and saturation component of for disease detection. So the image below represents the image in terms of hue, saturation, and value for brightness, which makes it easy for manipulating specific aspects of an image, such as adjusting the brightness of the chili leaf image without affecting its color information. Hue is used to isolate the discoloration. Saturation indicates the intensity of vividness, color which help to highlight the disease patch, and value represent brightness, which is less critical for color features enhancement. The original image is the unprocessed healthy chili leaf image. Original hue Saturation and value channels are the individual channels from the HSB color model, where hue is used to isolate the color tone, saturation is used to adjust intensity of color, and value is used to modify the brightness. Enhanced hue, saturation, and value channels are designed to bring out the specific details to highlight on the particular patterns or features on the healthy chili leaf image. Enhanced image with RGB is reconstruct version, which combine the enhanced channels to create a more vivid, finer diagnostic result. The next technique is image compression without loss. It's performed using discrete concise transform (DCT), which is used to reduce the file size while maintaining the original image quality. Discrete cosine transform is a type of fast computing Fourier transform which maps real signal to corresponding value in the frequency domain. It works on the real part of the complex signal because most of the real-world signals are real signal with no complex components. Lossless image compression is to compress chili leaf image using DCT-based lossless compression while preserving essential features for disease chili leaf image analysis to ensure the efficient storage and transmission of high-resolution images. This is the result of image compression without loss. Based on the figure below, the original image is the grayscale version of leaf spot chili image that shows the features and textures such as obvious leaf spots. The compressed image reduces the dynamic range and the detail information of the original image slightly, potentially for size reduction. So based on the figure A08, the file size of the original image is 11.65 kilobytes, while the compressed image file size is 8.16 kilobytes. This indicates the original image has been compressed without significant loss of the features and the detail information. Next, I will explain the contrast adjustment technique. This technique is used to enhance the visibility of subtle disease features in chili leaf image. The approach to perform contrast adjustment is histogram equalization. Histogram equalization is used to improve the image contrast, making faint discoloration caused by early stage infection more discernible for analysis. The main step involved in histogram equalization are as follows. The first, we compute the histogram of the input image. Second, we normalize and resulting the histogram to the range of 0 and 1. And then, the third step is transfer the normalized histogram to a color table. And lastly, we transfer the input image through the lookup table. This is the result of contrast adjustment. The original grayscale image contains the intensity values from 0 to 255, which is from black to white. The middle image represents the histogram equalization image, which is responsible to enhance the contrast of an image by redistributing pixel intensities to span the full range 0 to 255. And the histogram shows the pixel intensity distribution of the equalized image. The more uniform the equalized image appears in histogram, the more even the pixel intensities distribute across the range. Okay, now I will explain the morphological operation technique. This technique is used to enhance the image quality and improve the accuracy of the analysis, which is specifically designed for binary image. It applies a structuring element to an input image and create the output image at the same size where its pixels in the output image is based on a comparison of the corresponding pixel in the input image with its neighbor. There are two types of morphological operation. The first one is erosion. Erosion removes pixels on object boundaries, which makes object more visible and fill in the small holes in object, while the lines may appear thicker and fill shape may also appear larger. The second is the dilation. Dilation adds pixels to the boundary of objects in an image erosion. The remaining lines may appear thinner and the shape may appear smaller. And this is the result of the morphological operation. The binary image is generated by thresholding, in which the pixel intensities above a certain value are set to white foreground and the other are set to the black background. The middle image is the erode image, which removes pixels from the edge of white region foreground, making objects smaller and eliminating small noise. The right side image is the dilated image, which adds pixels to the edge of white region and enlarge the objects. It is commonly used to fill the small gaps or holes within the objects. So based on the left side of the figures, A10 show the image is converted to grayscale, binary erosion performed, dilation performed, and lastly the erode and dilated image are saved. The last technique is background removal. This technique is used to remove irrelevant background elements such as soil and lighting artifacts from diseased chili leaf image and enhance the visibility of disease features for accurate and precise analysis. There are two approaches to perform the background removal. The first one is color space transformation. It's convert image from RGB, red, green, blue to HIV, hue, saturation, and value. The input of the diseased chili leaf image is in the RGB color space, which is suitable for general image display, but it's not optimal for separating objects based on the color. The second approach is binary masking. In the binary image, pixel with the value of 1, which is representing the leaf, where the pixel with the value of 0, which is black, is represent the background. The middle image is a binary mask generated from the original image, which highlight the leaf as the foreground white while setting the background to black. The right image represents the background removal image. The process image where the leaf is segmented from the background via binary mask. At the same time, the background has been replaced with the black. In conclusion, this project introduced a robust image processing framework using Matlab to enhance disease features in chili leaf image for accurate plant disease identification. Techniques such as edge detection, sober and canny, noise cancellation, median and Gaussian filters, enduringly improve image clarity and sharpness. Color adjustment such as temperature and HSV-based enhancement and contrast enhancement highlights the disease patterns, while lossless compression optimizes the storage without quality loss. The morphological operation and background removal refine binary image and isolated disease area for precise analysis. The framework set a foundation for integrating machine learning models, advancing precision agriculture with scalable and reliable solution. That's all from us. Thank you.